You just bought undercoating for your car. Maybe it's new and you want to protect it. Maybe it's older and you're trying to stop rust before it spreads. You spent the money, did the research, read the reviews. The product promised permanent rust protection, factory-grade coverage, lifetime durability. You applied it yourself or paid a shop to spray it on. 6 months later, you notice bubbling paint on the rocker panels. A year later, there's visible rust creeping through the undercoating itself. 2 years later, the frame has holes and the rust is worse than if you'd done nothing at all. And you're standing there wondering what went wrong. How did a product designed to prevent rust actually accelerate it? The answer is going to frustrate you because it's simpler than you think. And the industry has been selling you the wrong solution for decades. Undercoating isn't inherently bad. What's bad is applying the wrong type in the wrong way to the wrong surface and expecting it to save a vehicle that's already compromised. Most people treat undercoating like a magic shield. Spray it on and forget about it. But rust doesn't work that way, and neither does prevention. Rust is an electrochemical process that requires oxygen, moisture, and metal. Undercoating is supposed to create a barrier that eliminates one or more of those elements. But if you trap moisture against bare metal or apply coating over existing corrosion, you've just created a sealed environment, where rust can spread invisibly and aggressively without you ever knowing until structural failure occurs. Here's what's really happening. There are 3 main types of rubberized, oil-based, and wax-based. Each one works differently, and each one fails differently when misapplied. Rubberized undercoating is thick, black, and permanent. It's what most people think of when they hear the term. It creates a hard shell that's supposed to block moisture and road debris, but rubberized coatings have a fatal flaw. They don't penetrate, they sit on top of the metal. If there's any existing rust, any surface contamination, any moisture trapped underneath during application, that rubberized layer seals it in. Rust continues to spread beneath the coating. By the time you see bubbling or cracking on the surface, the damage underneath is severe. And because rubberized coatings are difficult to remove, inspecting or repairing the metal becomes nearly impossible without sandblasting or grinding, which damages the substrate even further. Oil-based undercoatings work on the opposite principle. They're thin, penetrating, and designed to displace moisture while providing a sacrificial barrier that needs regular products like fluid film, wool wax, and similar lanolin or petroleum-based treatments creep into seams, coat threads, and migrate into areas that spray coatings can't reach. This is the type of undercoating that actually works for rust prevention, but only if applied correctly and maintained annually. The problem is that most people don't want annual maintenance. They want permanent protection, so they choose rubberized coatings and then never inspect the underbody again until something breaks. Wax-based coatings fall somewhere in between. They're thicker than oil-based treatments but not as permanent as rubberized. They provide decent moisture resistance and some self-healing properties, but they also require reapplication, and they can trap moisture if the surface isn't properly prepared. The key difference is that wax-based coatings remain somewhat soft and don't form an impenetrable shell. That means they allow some breathing and moisture migration, which can be good or bad depending on your climate and exposure conditions. And this is the part nobody explains. The effectiveness of any undercoating depends entirely on surface preparation, application, method, climate, and maintenance schedule. If you live in a dry climate with minimal road salt exposure, a one-time rubberized coating might last decades without issue. If you live in the Rust Belt where roads are salted 6 months a year and vehicles are exposed to freeze-thaw, cycles that create constant moisture intrusion, that same rubberized coating will fail catastrophically because moisture gets behind it, freezes, expands, cracks the coating, and allows salt water to pool against bare metal in a sealed pocket. I've seen this repeatedly. Customer brings in a truck with factory undercoating applied by the dealer. 5 years old. Entire frame is rusted through in sections. The undercoating looks perfect from a distance. Smooth, black, intact. But when you tap it with a screwdriver, it's hollow underneath. The metal has turned to rust, dust, and the coating is the only thing holding its shape. Peel back a section, and the frame literally crumbles. This isn't a product failure. This is a methodology failure. The coating did exactly what it was designed to do. It created a moisture barrier, but because the surface wasn't clean and dry before application, and because the vehicle was exposed to road salt that migrated through panel gaps and drain holes, moisture accumulated behind the coating and stayed there, accelerating corrosion instead of preventing it. Here's the real problem. The undercoating industry profits from selling permanent solutions to people who don't want ongoing maintenance. Rubberized coatings are marketed as lifetime protection because that's what consumers want to hear. Apply it once, never think about it again. But vehicles are dynamic systems. They flex, they vibrate. They experience temperature swings from -22 plus 120 degrees Fahrenheit. Coatings crack, seams open, water intrudes. And once water gets behind a sealed coating, it doesn't evaporate. It sits there and does what water does best. When combined with metal and oxygen, it creates rust. The alternative, oil-based annual treatments, are harder to sell because they require commitment. You have to reapply every year. You have to accept that your underbody will look wet and might drip slightly for a few days after application. You have to deal with a product that smells and doesn't provide the visual satisfaction of a clean black rubberized finish. But oil-based treatments actually prevent rust because they displace moisture, they penetrate into seams and crevices, and they're designed to be refreshed regularly, so you're inspecting the underbody annually and catching problems early instead of sealing them away. Until catastrophic failure, let's break down some myths. Most people think that undercoating prevents rust by creating a physical barrier, and in theory, that's partially true. But the reality is more complicated. Rust doesn't just happen on exposed surfaces. It happens in crevices, inside box frames, between overlapping panels, in spot weld gaps, and in areas that no spray coating can effectively reach. These are the areas where rust actually starts on modern vehicles. And if your undercoating doesn't penetrate into these spaces, or if it seals them off without displacing existing moisture, you've just guaranteed that rust will develop invisibly. Then there's the myth that thicker is better. People see a heavy coating and assume it's more protective. But thickness without adhesion and flexibility is a liability. Thick rubberized coatings are rigid, they don't move with the metal. When the frame flexes or the body panels expand and contract with temperature changes, thick coatings crack. Those cracks become entry points for moisture. And because the coating is thick, the moisture doesn't evaporate. It wicks along the crack, spreads laterally under the coating, and creates widespread corrosion that you can't see until the coating starts bubbling or falling off in sheets. Here's another big one. Factory undercoating is sufficient. False factory undercoating, when present, is applied for sound deadening and to meet minimum corrosion warranty requirements. It's not designed for long-term rust prevention in harsh climates. Manufacturers know this. That's why they offer separate rust-proofing packages and extended corrosion warranties. The base factory coating is a thin layer of wax or asphalt-based product that provides maybe 3 to 5 years of protection under ideal conditions. After that, it degrades, and the vehicle is vulnerable. If you live in a salt state and you're relying on factory undercoating alone, you're going to have rust issues by year 7 or 8, regardless of how well you wash the vehicle. Most people also think that undercoating can stop existing rust. This is dangerous. Undercoating over rust doesn't stop the process. It hides it and often accelerates it by trapping moisture. Rust is a chemical reaction. It requires intervention at the chemical level. That means rust converters, mechanical removal, or complete panel replacement. Coating over rust is like painting over mold. It looks better temporarily, but the underlying problem continues to spread and eventually breaks through worse than before. Now let's talk about the damage mechanism itself. Rust starts at the microscopic level. A chip in the paint, a scratch in the coating, a crevice where moisture can collect. Iron oxide begins forming. It expands. Expansion creates pressure. Pressure cracks protective coatings. Water intrudes through the crack. The cycle accelerates. On an uncoated vehicle, you can see this happening. You notice surface rust and you address it. On a vehicle with improperly applied undercoating, this happens invisibly. By the time the coating shows damage, the metal underneath is often too far gone to save without major surgery. Bonded contamination accelerates this. Road salt doesn't just sit on surfaces. It bonds chemically. It creeps into seams. It migrates through capillary action into areas you can't spray or wash. If you apply undercoating over salt-contaminated metal, you've locked that salt in contact with the substrate permanently. Every time the humidity rises or temperature fluctuates and condensation forms, that salt activates and the metal This is why pressure washing the underbody and chemically decontaminating before any coating application isn't optional. It's the difference between protection and accelerated failure. Here's how to detect whether your undercoating is working or failing. Tap the coated surfaces with a screwdriver or small hammer. Healthy metal sounds solid. Rusted metal sounds hollow or flakes. Look for bubbling, cracking, or peeling in the coating. These are signs that moisture is trapped underneath. Check drain holes in the rocker panels, door bottoms, and frame sections. If they're clogged with undercoating, water can't escape and it's pooling inside sealed cavities. Inspect the coating for flexibility. Press on it with your thumb. If it's rock hard and brittle, it's likely cracked internally, even if it looks intact on the surface. Certain factors make undercoating failure more likely. Vehicles in northern climates with heavy road salt use, coastal vehicles exposed to salt air and humidity, trucks used for off-roading that experience constant debris, impact, and coating abrasion, vehicles that sit unused for long periods allowing moisture to accumulate without evaporation, older vehicles with existing rust that someone tried to coat over, any vehicle where the coating was applied without proper surface prep or without addressing existing corrosion. So what's the fix? If you're starting with a new or rust-free vehicle, the best approach is oil-based annual treatment. Fluid film, crown, NH oil undercoating, or similar products applied yearly to a clean, dry underbody. This provides active rust prevention, allows for annual inspection, and penetrates into areas that permanent coatings can't reach. If you want a more permanent solution, use a wax-based coating designed for automotive underbodies, applied to a chemically clean and completely dry surface, with annual reapplication in high wear areas and regular inspection of critical points. If you already have rubberized undercoating and it's intact with no visible damage, inspect it annually. Tap test the metal underneath. Look for cracks and seal them with additional product, or remove and recoat sections showing failure. If the coating is already failing with visible rust underneath, you have two options. Remove the coating entirely, treat the rust, repair or replace affected metal, and start over with proper preparation. Or accept that the vehicle has limited remaining structural life and plan accordingly. Prevention starts before the coating. Pressure wash the entire underbody to remove loose dirt, salt, and debris. Use a degreaser to remove oil and grime. Apply a rust remover or converter to any surface oxidation. Rinse thoroughly and allow to dry completely. This can take days in humid climates. Do not apply coating to wet metal, ever. Once the surface is clean and dry, apply your chosen product according to manufacturer specifications. For oil-based treatments, that means spraying into cavities, seams, and open frame sections, then coating all exposed surfaces. For rubberized or wax-based coatings, apply in thin, even layers, allowing proper cure time between coats, and avoid building up thick sections that will crack. Let's talk cost. An annual oil-based treatment runs $100 to $200 if you do it yourself, or $300 to $500 if you pay a shop. Over 10 years, that's $2,000 to $5,000. A professional rubberized undercoating application costs $500 to $1,500 as a one-time expense. Sounds cheaper, right? But if that rubberized coating fails after 5 years and you need frame repair or replacement, you're looking at thousands to tens of thousands depending on the vehicle and extent of damage. Rust repair on structural components often exceeds the vehicle's value, effectively totaling it. The takeaway is this: undercoating works when it's the right product, applied the right way to the right surface, with the right maintenance schedule. The industry sells permanent solutions because that's what consumers want to buy. But rust prevention isn't permanent. It's an ongoing process that requires inspection, maintenance, and intervention. You can't spray a product once and expect it to protect a vehicle for 15 years in a harsh climate. That's not how corrosion works. The vehicles that last decades in rust-prone areas aren't the ones with the thickest they're the ones that get annual oil treatments, regular washing, and immediate attention to any paint chips or coating damage. If you've been sold on rubberized undercoating as a permanent rust solution, you need to reevaluate your approach. If you applied it yourself without proper surface prep, you might be accelerating rust instead of preventing it. If a shop applied it and promised lifetime protection without explaining the need for inspection and maintenance, they sold you a product that will likely fail. The question is whether you're willing to take a different approach or whether you're going to keep trusting marketing over methodology until the frame of your vehicle is too compromised to repair. Let me know in the comments what type of undercoating you're using and whether you've experienced rust issues despite treatment. If this breakdown changed your understanding of how rust prevention actually works, hit the like button and subscribe for more technical content that cuts through industry myths and focuses on what actually protects your vehicle long term. Next video, I'll be covering why your paint protection film is failing prematurely and how installation quality matters more than brand or warranty. Until then, inspect your underbody, question permanent solutions, and remember that rust prevention is a process, not a product.